Welcome to the section titled, Extending the V-Lab Environment with VR Affordances, of the Development of a Virtual Lab for Programmers course. This section aims to serve as an introduction to VR application development with the Unity engine. More specifically, the section presents Unity's plugin-based infrastructure for leveraging modern XR equipment in a transparent fashion, and stresses the key fact of built-in support for the OpenXR standard. Additionally, it presents the XR Interaction Toolkit, which facilitates XR development to a great extent with ready-made components and tools. Also, it presents the VR project template, which is a great way to begin with a complete, fully functional project and tailor it further based on the needs of each individual application. The XR plugin framework relies on Unity's input system, which allows for easy, conceptual definition of interactions and adds even more transparency and hardware independence. Through the XR plugin framework and its supporting packages, Unity supplies the developer with a number of ready-made components and tools, aimed at facilitating dealing with key tasks such as immersion and tracking of the position and rotation of equipment such as HMDs in 3D space, navigation around the scene and teleportation to various target locations, interaction with objects, including grabbing, moving, activating, throwing, selecting multiple objects, etc. Additional features are also available to address more specialized needs, such as gaze and eye tracking, access to vendor-dependent functionality, and more. One of the key features of Unity's XR framework is that it encompasses an event-driven application development logic, thanks to which the developer does not need to continuously poll for hardware input, scene interactions, etc., but rather defines what should happen when specific conditions are met or events triggered, such as when tracking input from a headset is received or a user's selection ray intersects with an interactive object. The framework is designed and implemented in such a way that everything is configurable via the editor. Nevertheless, additional functionality can be developed thanks to available based components. To begin development with XR in Unity, the first step is to install the XR plugin framework package. The package is optional and is not included by default in every project, much like the input system package. To achieve that, select Project Settings, then XR Plugin Management, and click on Install XR Plugin Management. This will result, among others, in additional settings available under Project Settings, the XR Plugin Management package installed in the Package Manager, and a folder under the project's assets, titled XR, containing essential assets for the operation of the framework. Additionally, a new main menu entry, titled XR, is available, as well as an option, also titled XR, in the editor's scene hierarchy context menu. When XR plugin management is first installed, the developer has the option to enable one or more plugin providers. These are essentially driver components that know how to communicate with specific devices, control them and direct their input to the rest of the framework. All settings are per platform, so the developer can define different settings for desktop, server, Android, and other platforms. One such provider plugin is titled OpenXR. Its purpose is to leverage the OpenXR standard so as to transparently address a range of compliant devices. Most modern devices such as Meta's Quest and HTC's Vive ranges of headsets and controllers are compliant and can be used in such a fashion. This logic also adds the tremendous benefit of being able to work with different XR equipment with the same codebase, without the need for any vendor-specific implementation. The framework also offers an additional tool, the XR Project Validator. This tool continuously monitors the overall project setup and identifies issues that may affect the application's operation or not permit it to operate at all. In some cases, automatic fixes are also available. Immediately after the first time the framework is installed and a plugin provider is enabled, the project validator will most likely report that there is no input system interaction profile defined. This means that there are no bindings between the actual controls supported by the plugin and the input system's actions available to the application. To address that, a developer would normally have to define an interaction profile by hand. This is a quite demanding, time-consuming and tedious task, even though the OpenXR standard standardizes the way hardware controls can be located, read, and written to. Also, it is something that is required for each and every application, as many base interactions, such as movement and object activation, are common to many, if not all, scenarios of immersion into an interactable world. As will be shown later, Unity addresses that via the XR Interaction Toolkit. Unity also offers comprehensive documentation, including examples and training options for its XR features, framework, and tools. The documentation covers, in great detail, everything from key concepts, architecture and plugin configuration, to platform support, support packages and recommended development and deployment workflows. The Unity registry also includes numerous support packages, aiming to address fundamental needs, such as the definition of input system interaction profiles discussed above, as well as more specific, specialized needs that may not pertain to each and every application or development environment, such as virtual hand control, augmented reality functionality, virtual devices, and more. Developing with XR in Unity, with a focus on VR, may begin with a typical, empty 3D project or a ready-made template. When working with an empty project, the first task is to convert the standard main camera, meant for desktop rendering, to a VR-enabled camera, that is, a camera whose position and orientation is driven by the position and orientation in the physical space of an immersive device such as a head-mounted display. To achieve that automatically, after making sure that the XR plugin management package and plugin providers of interest are installed and properly configured, right-click on Main Camera, then select XR, and convert Main Camera to XR Rig. The camera is then converted to a game object hierarchy that includes a number of additional components meant to support scene camera position and orientation real-time update based on tracked immersion device, e.g., head-mounted display, and scene camera viewpoint positioning with respect to real-world floor or initial position of immersion device in 3D space. The component responsible for positioning and rotating the camera in the scene based on input from the tracked immersion device is the tracked pose driver. The components offers a set of basic settings to select the input device from a set of potentially more than one available, set the tracking reference point, enable or disable position and orientation tracking, the update timeline, and more. The XR plugin management framework and XR plugins offer pretty much nothing else as regards VR functionality. For example, in the base setup described so far, there is no way to handle controller input or perform key interactions such as movement and object activation. All those would have to be manually programmed by the developer and appropriate input system actions would have to be defined to drive them, which is a tedious, repetitive, demanding, time-consuming task. This is where Unity's XR Interaction Toolkit, or XRI for short, one of the support packages available becomes necessary. It solves the problem by offering a wide range of ready-made components, configuration, and tools. XRI is available as a package via the Package Manager. To install it, see for XR Interaction Toolkit in the Unity Package Registry. After installation is complete, there is a new folder in the project's assets, titled XRI, that contains essential settings but no reusable components yet. The next step is key and empowers the developer with a range of reusable components, settings and tools so that focus can be given on the actual application in Logic rather than the development of essential, low-level fundamentals such as navigation and interaction. More specifically, XRI offers numerous samples to kickstart development. These include starter assets, which should be installed almost always when using XRI, and many others, ranging from virtual hands, a virtual keyboard, and more. To begin, import the starter assets sample. As a result of that last action, a new folder, titled Samples, will be created. Under that folder, the XRI starter assets are available, including, among many other things, a default set of input actions for OpenXR compliant and other popular equipment. You can, and should, use that with your enabled plugin providers of choice. Keep in mind, however, that you may need to make adjustments and additions to the default input system set, in which case it would be wisest to not make those onto the original sample asset but on a fresh copy you shall create for the project. The default input actions set is found under Starter Assets. The package also includes a demo scene, various models and animations, helper scripts and various prefabs. As mentioned earlier, Unity aims to facilitate working with XR even further, and, to that end, it offers a project template for VR, ready-made with basic setup, a sample scene, and numerous interactions. This is available when creating a new project under VR Core. As practice for this first lesson, create a basic, empty project, fully enabled with XR plugin management, the XR Interaction Framework, and the XR Interaction Framework's samples. Add a VR-enabled camera and verify its operation. Also, browse through the XR Interaction Framework's sample assets, load and explore the demo scene, and try and reuse available models, scripts, prefabs, etc., into your own test scenes.